My name's Benjamin, and I'm here to talk to you this afternoon about Spirulina as a dual-purpose lamb supplement and how this affects product quality and productivity. First of all, I've got to apologise, I haven't talked academically for a while, so you've got to excuse a few of my terminology slip-ups. So today I'd like to talk to you about I'd like to give you a brief overview of what products are, what Spirulina is, what we're investigating and why we're investigating it, how we did it, what we found, and who this affects, to summarise. And just as a viewpoint, you never should see a sheep smile like that in real life. So also, it's probably best I begin with the acknowledgements. So a big thanks to my supervisors, Aduli and Richard, who are here today, and Peter, who I'm afraid couldn't make it. Also, there's a lot of other thanks there, but I'll say thanks to you after the presentation. Now, during this PhD study, I was fortunate enough to be published a few times, so I've put these on the first few slides so you can understand. I'm having to be pretty brief with my overview of the findings, and if you feel the urge and there's any questions that I haven't answered today, feel free to look these up and have a read. Also, I've been lucky enough to I'm attending a conference later this year and have co-authored a couple of book chapters with Aduli. So first of all, what is Spirulina? Now, it sort of tastes like it looks. It's a cyanobacteria, formerly a blue-green microalgae, but you can understand the blue-green bit not adding well to the marketability of it. It's typically grown in a liquid medium, so it naturally occurs in the alkaline lakes in South America and Africa, and it was actually used as a traditional food source by the ancient inhabitants, but it fell off the radar a fair bit, and it was rediscovered back in the 1960s, where it's become trialled with livestock. Now, this trialling with livestock stems from its nutritious and its vitamin-rich composition, which is one of the reasons why it's been labelled as a supergroup in a lot of those health drinks and health shakes. If you got a Boost Juiced over in Eastlands and ask for Spirulina, this is the stuff that you get in it, the same stuff we fed our sheep with. But with sheep, the main interest is the high protein content. With 65% protein, this has huge applications in promoting the growth and productivity of lamb. But also the vitamin Bs and the antioxidant effects of these do have big effects on product quality as well. Now, when you produce sheep, generally you're after wool. But how do we test to see whether wool is good wool or bad wool? This comes down to having a look at the physical quality traits of the wool fibre, basically fibre diameter and many related measurements. As a rule of thumb, finer is better. I'm sure we've all had itchy jumpers given to us for Christmas. This is due to coarse wool being used, so now there's no excuses. And the coarse wool is generally adapted for carpeting, whereas the fine wool for apparel and fine Italian suits. This is the more tastier of the lamb products, the meat. And when you're judging meat quality, generally you can divide it into two components. The nutritional, which basically refers to, will eating this give me a heart attack? Especially the omega-3s and the unsaturated fatty acids ratio to fatty acids, and also the sensory traits, which, as Caroline said, it's the taste of the lamb that's the important effect. Now, the productivity of these products, this adds to the financial viability of production. So at present, meat prices are comparatively high to where they were, say, 10 years ago. And this is due to an expanding local market and also an expanding market overseas. I think right now Australians are eating a lot more lamb per capita than they have in the history. And this is sort of working negatively parallel, if that's a correct term, with wool prices, which 10 years ago sort of flattened right out, and only just now we're seeing a slight recovery in the prices. And this is due to a lot more people using nylon and rayon and a lot of other synthetic fibres, which you can standardise more so you don't get the itch factor. So ideally you'd think, right, well, we'll get rid of all the wool in sheep and just go and produce meat, but there's several reasons why this isn't a wise move, and you should aim on keeping dual market focus. And this is because it adds a sort of buffer in case one market declines, all your eggs aren't in the one basket. But also it actually keeps the farmer happy, because as Aaron told me a few years ago, if you try and tell a farmer, a 7th generation merino farmer, to get rid of his prime breeding stock that his great grandfather worked on, he's going to chase you out of the property with a shotgun. But in dual purpose production, productivity is driven by protein supplementation. I've sort of leaped ahead, thus spirulina. But spirulina is also useful for dual purpose production because traditional supplements are prone to land encroachment, so urbanisation, and even natural parks, national parks, encroaching onto traditional farming land, increasing prices by their use in other areas of agriculture. And we're looking at supplementations that improve product quality to match consumers' desires rather than just getting more product. So you're going to have to excuse me while I read this, because this was the objective of the study. So the one on the top, to test the effects of spirulina supplementation and its interactions with lamb sire breed, sex and plane of nutrition on product quality and productivity. Now, as a secondary objective, we wanted to look at the effects of sire breed, sex, plane of nutrition, and their effects independent of spirulina on these parameters as well. So how did we do this? Over 2 years and saw back, we ran 2 feeding trials. So in both years, we'll start with first year, we had a balanced experiment, which was balanced by gender, so male and female, or in our fact wethers, but I couldn't find a symbol for wethers, so male will do. And 4 sire breeds, we had black Suffolk, white Suffolk, Dorset, and a purebred merino to act as sort of a comparison to the industry. And we fed these 2 levels of spirulina and had a control group. The following year we couldn't get access to black Suffolk sheep, so we had to just use the white Suffolk, Dorset and purebred merino, but we added another supplementation level in there after preliminary results showed medium supplementation levels to be optimum for product quality and productivity. So every day on the trial, it ran for 9 weeks, we supplemented the sheep with their the lambs with their respective dosages using an oral drench. And at the start and end of the trial, we also took mid-side wool samples, as you can see Arash and Chris doing it there, to test for the wool quality attributes. And then just at the end of the trial, we took meat samples. But, so we're going to have to jump back a bit here. We also took blood samples during the trial and weekly measurements of body conformation traits, so how fat the lambs were, body condition scores, how high they were. And then ultimately ended up in the laboratory looking at fatty acid composition. And I've got to thank Will Bignell for this picture up here. We didn't use canola, but the photos I took of the extraction I did didn't quite pan out as planned. So the findings. With wool quality, we found that spirulina supplementation didn't have any effect on fibre diameter or the majority of wool quality traits. Now, this might seem a bit strange, but that's good news, because the majority of traditional protein-rich supplementations tend to negate wool quality significantly, such as if you feed your sheep canola, you get a lot coarser wool, and that's not preferable. However, we did find that it did increase your wool yields, so your clean fleece yields. And so As an average they did, but I thought it was more interesting dividing it up into plane of nutrition. So we've got lambs fed at a typical, which is pasture grazing on improved ryegrass, and drought, which was simulated drought conditions where they were fed lucerne hay. And you'll see that yield increased incrementally with spirulina supplementation level in both respects. Also, spirulina interacted with sire breed to affect the coefficient of variation of wool fibres and standard deviation of wool fibres, which means the variation, because not all wool is the same diameter on a sheep's fleece. So this sort of talks about the bell curve of where the fibre falls into its microns. I'm even confusing myself then. The variation within the wool sample of microns. Now the growth level, this is exciting because of the high value put on the meat products. Again, as an average, we showed that spirulina supplementation improved lamb live weights at medium levels in far excess to high and low levels and the control. But again, it's more interesting if you split up the results to how they acted in simulated drought conditions comparative to grazing conditions. And as you can see with the drought conditions, that medium levels of lambs supplemented at medium levels grew to a much larger weight than those fed at low or high. And this is useful because spirulina is not exactly the cheapest thing out there, so it allows more optimal supplementation and cost-effective use of what you've got. Now, well, as you can see, we actually bought spirulina for $60 a kilo, so it's up there. But ultimately it all comes down to economy of scale. That seems like a bit of a cop-out, but if you buy a ton of spirulina, it goes down to about $5 per kilo. So with what we found with our growth responses, if you supplement lambs at the medium levels we used for the 9 weeks, so the duration of our feeding trial, and you only paid $5 per kilo of spirulina, you'd in essence make an extra $5 per head of lamb you've got. So if you've got a flock of 1,000, that's not loose change. And hopefully these prices will drop even more with the work that's currently going on in biofuels and work with microbes. Now, anyone who's drunk spirulina in one of those health drinks will be happy to know that feeding spirulina to sheep didn't kill them. So there was no detrimental effects as shown by the haematological parameters. In fact, we found that creatine and glucose increased with spirulina supplementation incrementally, and as both of them are biomarkers of lamb muscularity, that's a good sign. It means there's a lot more muscles in the sheep that are getting spirulina. We also found that spirulina interacted with lamb sire breed and sex on these parameters as well. Now, meat quality. With the way my project was directed, I focused on the effects of sex and sire breed and plane of nutrition on these fatty acid parameters of the project. I'm afraid you'll have to wait a bit longer to hear the effects of spirulina on these fatty acid profiles. But we tested 5 different tissue types, so subcutaneous adipose, heart, liver, kidney, and my Latin's terrible, longissimus dorsi, muscle, which is sort of the back muscle going down the back of a sheep. And unsurprisingly, we found that tissues differed in fatty acid composition. We also found that when pasture-fed lambs had more fatty acids in their tissues than those fed simulated drought rations. Now, when I say more, there was a greater content of fatty acid opposed to there being a greater spread in the profile. Also, polyunsaturated fatty acids increased with grazing, and this is useful because these are the good fatty acids. These are the ones that are advised to limit cardiovascular disease. Also, fatty acids varied with sire breed, so you can breed your flock up so that you can optimise the content of specific fatty acids, whereas gender didn't affect it too much, so it doesn't matter what's in your flock so long as the breed's correctly selected. But if we talked about all the fatty acids that were analysed, we'd be here until the long weekend's over, so I thought I'd focus on the healthy ones. So these are your long-chain omega-3 fatty acids. So these, if you've ever taken fish oil tablets, this is what's in those, so your DPAs, your DHAs. And if you look at these results, you can sort of tell on the majority we eat the wrong bit of the lamb. We should be eating the liver opposed to the muscle if you're chasing these long-chain fatty acids. But it was interesting, high and low. High, it's just with this graph, high means pasture-fed, low means simulated drought. So you can see that there's a significant difference in fatty acid content, or the long-chain omega-3 fatty acid content in the tissues dependent on the basal diet that the lambs received. This was also found between sire breed, so again, if you want to be healthy, you want to eat the liver tissue of lambs kept in pasture grazing of black Suffolk sire. But again, below you can see again, gender didn't really affect these results to any great extent. Now, as a preliminary investigation of the fatty acid content of the lamb's meat, we conducted a fat melting point investigation of the adipose tissue and an intramuscular fat test, and it was found that fat melting point increased with spirulina incrementally. Now, the fat melting point is directly related to composition and saturation of fats. So the higher melting point indicates that there was an increased level of saturated fats comparative to unsaturated fats. So sort of a preliminary insight to match onto the profiling we did later. We also found that IMF was not affected by spirulina, but if we split up the results to have a look at the drought compared with the pasture, we actually find that intramuscular fat levels were increased with spirulina supplementation during drought, which looks like we don't need to worry about this winter. I think lastly, the feed intake and how that was influenced by spirulina supplementation was investigated. We found that feeding sheep spirulina didn't affect how much they ate, which in turn indicates that the growth responses that we witnessed were not caused by spirulina acting as a basal diet promotant, sort of making the sheep want to eat more. It ate the same but developed or grew with regardless. We also tested the basal diet's chemical compositions as well. So, who does this affect? Basically, this study has identified spirulina as an alternative protein-rich supplement for lambs. It's been previously used in rabbits, but hopefully this has got a bit more application. It also shows how to best cost-effectively supplement spirulina. You don't need it. More is not necessarily better when it comes to promoting productivity or product quality. We also hope to demonstrate how you can manage this product quality and productivity with spirulina by manipulating the sire breeds you use in production, the sex that you're predisposed to, and also the basal diet which is available for your lamb. Now, as with all studies, you reach the end and you think there's more you can do, but we believe that to carry on from this trial, investigating spirulina supplementation's effect on gene expression, nutrient partitioning and protein sinks, and also using other sire breeds which are more tailored to other production areas, say in international areas, would really complement and further expand on this study. So in conclusion, and I think this is basically the take-home message, spirulina has shown potential as a dual-purpose supplement for Australian lamb producers. Thank you for listening.